For the first experiment, we assemble a calorimeter, which is a device for measuring the heat developed of a certain type of reaction, and also calculate the heat capacity of a material. Calorimeters have been designed in a great variety. One type in widespread use, called a bomb calorimeter, basically consists of an enclosure in which the reaction takes place, surrounded by a liquid such as water that absorbs the heat of the reaction and thus increases in a temperature.
Build a unicell calorimeter and determine its heat capacity. Determine the specific heat of rock or metal and the heat of crystallization of sodium thiosulfate pentahydrate. For the process, we put a unicell glass inside another and then we cover with a lid of the same material. We put some water on it and then we add hot water to see the change in temperature. We repeat the process, but instead of hot water, we put a previously heated coin.
Objectives were completely achieved with our microscale calorimeter. For the practice, we handle different elements to test the performance of it and look how it works, as well as the variability of temperature and the thermochemistry. In the experiment, we applied knowledge in chemical kinetics, studies the speed of chemical reactions, and for this is an experimental study. The rate of any chemical reaction can be expressed as the variation of concentration over time. And we made an Eolin clock and we measure the calculations with the Arrhenius equation. Check the influence of concentration of the reactants on the reaction rate. Obtain experimentally the initial reaction speed and the partial orders of each reagent in chemical reaction. Graphically check the Arrhenius law and calculate the activation energy of a reaction by varying its temperature.
In this experiment, the kinetics of the chemical reaction were 2H plus 2I plus H2O2 becomes I2 plus 2H2O. The iodide reagent is generated from molecular iodine by adding vitamin C to tincture of iodine dissolved in water. Iodine tincture contains in molecular iodine and sodium iodide dissolved in ethanol and water. The following equation is I2 plus vitamin C becomes 2H plus 2I plus vitamin C. By adding the hydrogen peroxide to the mixture of vitamin C and iodine tincture, reaction 1 is initiated. Reaction 2 consumes the molecular iodine formed in reaction 1 as soon as it is produced, so that the concentration of I2 remains very low over time. When all vitamin C has been consumed in reaction 2, the concentration of I2 increases considerably in the solution and an iodine compound is formed with dark blue starch, which marks the end of the chemical reaction. The Arrhenius equation is a formula for the temperature dependence of reaction rates. The equation was proposed by Svante Arrhenius in 1889. Arrhenius equation gives the dependence of the rate constant of a chemical reaction on the absolute temperature, a pre-exponential factor, and the constants of the reaction, where K is the rate constant, T is the absolute temperature in Kelvin, A is the pre-exponential factor, EA is the activation energy for the reaction, and R is the universal gas constant.
To get the slope of the graphic, is necessary to obtain EA. And for this, first we need to get the values of orders x and y. After that, solve for it. And then it's necessary to obtain the value of the constant k. With these values, make the graphic. And we obtain EA with the equation of the slope 8.314 times the value for m in the slope. It is important to note that although the compounds we use in the lab has the same quantity and the same conditions in which they develop, they all not always will follow a pattern, but they give us an average to have our calculations.
In this practice, we'll learn that some experiments may need to be done more than once, because results can vary a lot and we need to be very precise and aware of all factors because temperature really affects the results. By doing them several times, we can get an average that shows more exactly the results, so then they can be considered for future calculations.
Chemical kinetics, thermochemical, and colligative properties are applied. The time of how long the concentration change to y depends in A and B, and also in the heat and the speed of the shake.